Welcome to Breadboarding. Does it run Tetris? This is the question we're going to be answering during this video, which is video 9 of the Nanocomp 6809 Breadboard Video Controller series. For those of you who may not be familiar with this project, this has been developed over a number of videos over the last number of months and is based on a design first published in Wireless World magazine in July 1981. So the main thing about this is that it's all built on breadboards, and you can see here we've got the original Nanocomp here with a keypad and display, LED display, and then over here we have the video controller that we've been developing over the last series of videos. So over here we've got the 6809 8-bit microprocessor, and then we've got the RAM, the read-only memory, the peripheral interface adapter that controls the keypad and the display, and then we also added a serial controller which is plugged in through a TTL serial adapter to a USB port on the PC. Then over here we've got our video controller, which is based on the 6845 video controller processor. We have some dual port RAM and some larger single port RAM which is used for the main video memory, and then this is plugged into a standard 15-pin VGA connector over on the side here. And down the bottom here we have our mini voltmeter that just makes sure that we've got the right voltages going to all the extreme areas of the breadboard. For those of you who want to get up to speed on this, there is a summary video for the main Nanocomp here that summarises the whole building over a 15-minute video and speeds up all of the construction sequences, so you can actually see what was going on over the whole series. And I will be doing a similar thing for the video controller once I've completed the next couple of stages. The next stage after this, we're going to be developing a 640 by 480 two-colour graphics display, and after that we'll be extending that to do 256 colours at 320 by 200, which is a sort of resolution that most DOS games were originally published at. So does it run Tetris or Doom is a common question for homebrew micros. Unfortunately, Doom requires an Intel 386 class CPU with 4 megabytes of RAM, so we don't really have much of a chance of running that type of software on this 8-bit micro of only 32k of RAM. But a Tetris-like game should be possible on the 6809, although we may need to do some optimization on it to get it to run smoothly. The Tetris Story by Vadim Gerasimov, who was one of the original developers, is quite an interesting read. I suggest you go to the site, the link that I'll put in the description for the video. And the key thing here is that he's provided a download of one of the very early versions of the DOS Tetris program. So what we're going to look at now is have a look in DOSBox and see what that looked like. So I've downloaded the zip that's provided here, and in DOSBox all we have to do is to mount the folder that's on the PC. So I've got all my software under CDOS, so this just makes C drive here, and we can see here Tetris 3 is the folder we want to be in. And if we then just run Tetris up. So we're just going to show the demo first. And can see here that there weren't even any line drawing characters for this. I suspect it's because it was written on Russian computers, which probably didn't have line draw characters because they use them for the Russian Cyrillic characters. You can see here that we've got basic controls, so 7 for left, 9 for right, 8 for rotate, and then a couple of others, keypads for the drop and speed up, etc. So I think we've only got a keypad on the Nanocomp, so we'll be making use of some of these. So you can see it's a fairly basic, and what we'll now do is to have a look at the current web-based version of Tetris to see how that has evolved. So here we have the current Tetris.com website, and there's a free to play here, although you occasionally get adverts. And you can see here this just uses the basic keypads and has the well-known background music. Now you can see here that very similar, a little bit prettier, and we also then have the hold on the left hand side, so if we want to swap out a current Tetronimo. So Tetronimos are the names of the shapes, and on the right we've got the upcoming Tetronymos and the score on the left here. So the score, the level, and the number of lines that we've completed so far. So that gives us our basic design. So we've looked at the Tetris story, looked at the original version, the early DOS-based version, and we've also looked at the browser game. There is some source code out there that I found. So the Tetris C using the Ncurses terminal library by Stephen Brennan is available on GitHub. We'll be looking at this in more detail, but if we have a quick look here, you can see here this is an animated GIF that shows the basic terminal-based version of this, and what we'll be looking at doing is replacing this terminal version to write directly to the Nanocomp video RAM, and it also has a boss mode in case you're using this at work. You can see here that we've got the next and the hold values are also here as well. So this provides a framework for this, and this is what we'll be using to see if we can actually get a version of Tetris running on here. Now that's going to require us to get a C compiler and get that working, and it's also going to require us to add some capabilities to the Nanocomp monitor so that we're able to get character output from C onto the screen so that we can use it for debugging. So let's now look at what our requirements are then for this version of Tetris. We're going to use keypad keys similar to DOS. So 7 for left, 8 for rotating the Tetronymos, 9 for right. Going to use 4 for drop, and I'll choose to use 5 for hold. So this allows you to put the current character into hold and swap. We're also going to then use the CN for cancel and S for suspend, since I don't have some of the other keys. The screen layout is 22 rows by 10 columns, and we're going to put that in the center, and we're going to have windows for next, hold and score, similar to the web example. Now what I'm going to do is to design some custom characters for Tetris, and I'm going to load those into the character generator RAM. I'm going to create those for the box and the Tetronymos, and I'm also going to need to implement a Nanocomp replacement for the Ncurses library. So the Ncurses or Curses library is a C library for interacting with terminal-based displays, and what it does is allows you to use Windows, and it has back-end processing to update the terminal based on the previous and the new version of the screen, and only updates those areas of the screen which need to be updated. Now, we're not going to be able to do that initially with a Nanocomp, so we may find that it's not that efficient and we may need to do a bit of tuning in future videos. Now, there are a number of dependencies that we need to be able to do this, so I'm not going to go through these in detail in this video. We'll cover these in much more detail in subsequent videos. This will include enhancements to the built-in Nanocomp monitor to handle screen I/O for C. So there's version 10 of the monitor that handles basic controls like line feeds, character turns, form feeds for clear screen and backspace. So this means that the output from the C print statements can be seen directly on the Nanocomp display, and we can use that for debugging. It's also required the installation of Windows Subsystem for Linux and Ubuntu, in that the C compiler and the assembler linker are only really supported on the Linux, and that requires then the installation of the CMOC 6809C cross compiler. So this can be run under Linux on Intel 8086 compatible computers, and will then generate the 6809 SREC format, which can be downloaded straight into the Nanocomp memory using the load function of the monitor. We're also then going to need to configure C to use the Nanocomp screen I/O for debugging, write a C keypad input routine so that the C code can read the Nanocomp keypad. These are all the things I've needed to put in place to get Tetris running. So I'm not going to cover all these prerequisites now, because I'm not sure that will be that interesting at this point in time. So what I'm going to do now is to show you the C source code for the Tetris, and show how we've then produced our own Nanocomp version of the Ncurses library that allows us to interact with the Nanocomp display. And then I'll be showing you running up the program and seeing whether or not we can run Tetris on the Nanocomp. So what we need to do first of all is to design the custom characters that we're going to use for implementing Tetris. So this will be for the boxes around the play area and the various other windows, and also the Tetronymo characters themselves. We're going to have the solid block Tetronymos and also the outline ghost ones that we use for the bottom of the screen. So we're in the DOS box here, and when we were looking at the fonts in one of the earlier videos for the VGA fonts, there was a DOS-based utility called Frapt, which is quite a good way of looking at characters and designing characters. So if we can look at any of the VGA characters here, but what we're just going to do first of all is to select the space here, and then this means that we can actually design our own characters. So what I wanted was the 4 pixels wide for the lines, and then I wanted some corner pieces. So this is like doing the bottom left hand corner piece, and so by doing this we can plan out how we want these characters to look, and you can kind of see what they look like on a, you can sort of just about see that you can see this in the cells here. So what we then do is to work out what the raster bitmap we need for this is. So this is byte 0, 1, 2, 3, 4, all the way up to 7. And we need to then create the values for these to load into the character generator ROM. What to do now is to have a look at these custom characters which have now been loaded into Video RAM. So first of all, I'm just going to do, as you can see here, the screen capture of the VGA output from the Nanocomp. So this is now on version 10 of the monitor ROM, which has now got these extensions to allow C programs to be able to write directly to the screen and do new lines and scroll the screen. So what I'm going to do first of all is just run a version of the test program that I've run previously. You can see here that on row 18 we have the top 16 characters here, and you can see their mathematical symbols. So F0 is sort of 3 bars, F1 is a plus or minus, F2 greater than or equal to, etc. So that's what the current characters are, and what we're going to be doing is replacing that last row of 16 characters with our custom ones that we're going to use for Tetris. So what I'm going to do first of all is to just run up the test program that I developed to display boxes and things suitable for Tetris. Now you can see here that I've also done a very simple animation of a Tetronimo and the outline ones at the bottom, which can be used to show where the current Tetronimo will fall. The characters look pretty good, that's what I want, and so we're going to be able to then use these characters in the C Tetris program to make it look pretty close to the web-based version of the Tetris program we saw earlier. And if we now go back and run our test program, what we'll be able to see is the bottom row on row 18, you'll see F0, F1. Those are now the left and right symbols for the box, the top, the bottom. F4 has just got all ones. Then we have the top left, top right, lower left, lower right, and then the F9 and FA are actually Tetronimo size. They actually have a 1 pixel border around the left and the bottom, and the FA has a 1 pixel border around the top, bottom and the right hand side. And then you can see FB and FC are in fact the outline ones that we're going to be using for kind of the shadow ones at the bottom of the board. This shows that our characters are looking pretty reasonable, and now all we need to do is to look at how to redevelop the ncurses library to work with the Nanocomp. So here we are back on GitHub, and what I've done is downloaded the code from here as a zip file. And what I did is expanded it into 2 folders. One is the original source code and the other is the one that I'm working on. And so what I'm going to do now is to look at WinMerge, and we're going to look at the key changes and things. So this has taken a number of days to do. I must admit my C programming is a little rusty since I haven't done much C in the last 20 years or so. I think I've just about got up to speed now. So apologies to anyone who thinks I'm doing this in a rubbish way, but I'm a little out of practice with it and I'm learning as I go along. What this is showing is where we've got here the main changes on the main.c, tetris.c, tetrisheader.c. There was also an ncurses header file referenced from the source code, and what I've done is created my own Nanocomp curses, NC curses I've called it, which has got some of the routines necessary to interact with the display. I found that it's probably going to be easier to do this because the way how the program's currently functioned is to use the ncurses library, and to change that would have broken an awful lot of things. So let's have a look at the main source code to start with. So there are a number of headers that we've had to modify. So CMOC and CMOC Extra are some headers that replace the standard IO, standard lib, and various other standard bool, etc. And you can see also on the right hand side you've got the N curses here. Now we've got NC curses, and I've also got some nanocomp specific routines, which include things like interacting with the clear screen routines and things like that. We don't need the utilities. And one of the other areas, the key areas here, is that this is one of the macros that are used to define adding a block to the screen and clearing a block to the screen. Now, the original code over here is using the W add character, and it uses this reverse attribute and a color pair given by the Tetronimo type here. And this is used to set the color for the character, and it's just using a reverse space here. So effectively, the full character is a full block. Whereas what we're going to be doing is using these custom characters that I've got. And what I found is, as you've seen in the earlier part of the video when we were looking at on the nanocomp, that these look a bit prettier and they have the borders around them, so you can actually see the 4 blocks making up each Tetronimo. This is one of the key things really that defines the update of the display, and the print color character is a nanocomp routine. So this print color character is built into the nanocomp monitor and makes use of the current cursor location or the current character location in 2 memory values I've called display column and display row, and it will just print the current character we've provided here at that position, and then we'll automatically move the position on, but we're able to override that with a nanocomp move function, which we'll look at in a bit. Then what we've had to do here is define, since we don't have this color pair function that exists in ncurses, we've got a local version of this. This just contains the background and foreground combinations for each of the Tetronimos, and we'll see that the Tetronimos are in different colors. So then there's a number of areas where the various ncurses functions are no longer needed, so I've commented those out. So that refresh will basically take the current memory values of ncurses and send the differences to make the terminal look like the new screen. So if you had only 2 or 3 changes between the previous screen and the new screen, it would only send those changes down to the terminal, from my understanding. Then we've got slight difference in the way how the score is shown, in that we've now in addition included a move function just to make sure that the score is spaced out a little. We've got a new version of the color pair init pair code, in that this has been re-implemented for the nanocomp rather than for ncurses. Then we get to the main function itself. So the first little bit of code here, we're having to override the default CMOC console IO handling, and so what this does is actually replaces the default console output routine with an nanocomp one. So this means any print functions we do from the C code will go directly to the nanocomp display, and that's useful for debugging. The clear screen function there just directly calls the nanocomp clear screen function, and there is a function within the nanocomp library that I've done for copy the character generator values into the RAM. There are quite a bit of the original Tetris source which have SDL music and sound extensions, so I've taken a lot of those out just because it was confusing a lot of the code. And because of that, some of the areas I've just removed chunks of code to make it simpler. What I have tried to do is, where there were obvious areas here where there were then ncurses functions that we didn't need, then I have just commented them out. So it should be relatively straightforward to compare the modified source with the original source. And you'll see down here that this is where we're setting up the new window functions for the board, for the next window, the hold window, and the score. And all I've done here is modify the layout a bit so it's more like the Windows version of the game rather than the character-based version that you saw in the animated GIF. So a lot of the functions remain the same. It's only really where we're doing things like the sleep and the polling characters, where I've had to replace those with nanocomp specific routines. And I've also changed some of the character mappings for some of the keys so that they're characters which are compatible with the nanocomp keypad. I've also renamed pause to be suspend just because it's the S character there. So the loop here is a fairly straightforward loop, and most of the functionality is in the tetris.c and the nanocomp.c. We've got a few extra statements down the end here. So this is my nanocomp move, the display current row and column. So all this does is modifies the variables for the current row and column so that when the next print statement runs, it's positioned the text to the right place on the display. So that's the main function. The final little bit there is, because there isn't an operating system on the nanocomp, then this return nanocomp in fact does a software interrupt, and what that does is goes back to the nanocomp monitor. So that's the main function, and it's the main loop is in there. Then I'm not going to go through everything in the tetris.c because that would take quite some time, but you can see here that we've got the changes from the header libraries. We've changed them to be the CMOC and the nanocomp. But the only change I've really had to make here is the gravity level that determines how fast the tetronymos fall down the screen. And in testing, you can see here that I've had to start with a very low value, in that as the difficulty of the game increases, that it gets to the 4 speed here. But because the nanocomp is a lot slower than the computer's probably written for this ncurses version, then I've had to reduce that. Now, one of the things I will be looking at in a future video is how to optimize this and perhaps to make it a bit more efficient so that it can run with a slightly less overhead than it has at the moment. There's a few minor changes I've had to do where the CMOC compiler was complaining about data types, so I've cast this particular output to be a byte value. And then the memory allocation model is slightly different on CMOC, and so the mallocs have been changed to be this SBRK, and the randomization seed srand I've just hard coded to a random value. I need to look at a better way of doing this, but I just didn't want to have it at 0 every time, so what I've done is put in a random value in there. Then again, where we're allocating memory for the Tetris game object, then we're just using the CMOC style of doing this, and then I've just cut out some of the save game, load game functions and things which you don't need. So very minimal changes to that tetris.c. The header file, we've just had to replace some of the standard library headers there, and I've replaced the empty string with, rather than being 1 space character, with 2 space characters, and the block is now my 2 custom Tetronimo characters there, rather than that Unicode value that we had in the previous version. Then I've commented out those functions that we don't need, such as load game and save game, and the print as well. So the very minimal changes. Most of the new code is in fact in the nanocomp and ncurses. So what I'm going to do now is to have a look at those, and then what we'll do is look at compiling it and running it. Now let's look at the nanocomp specific functions that I've had to write for this. So these are C libraries that are specific to the nanocomp. So what we've got here first of all are 2 functions, one to poll the keypad. So this will do a number of iterations of polling the keypad, then return. It's also then got conversion of the nanocomp key code into ASCII. And then there's the get key, which again does a very similar thing. This handles talking to the peripheral interface adapter port A and port B and polling the keypad exactly the way how the monitor ROM does in assembly, but this is now done in C. And then there's some wrappers for these that poll the keyboard and returns the nanocomp key code, and then does a lookup on the ASCII value. If the poll doesn't find any key returned, it returns FF, so effectively -1. And whereas a get character will only exit when a character has been entered. Then there's a wrapper for clear screen around the monitor routine. So F6DE is the monitor routine for clear screen. If we change the monitor, we'll have to change some of these values we've got in here. And then there's a couple of other functions here. So the print color character, again, is a wrapper, assembly language wrapper around the F695 function in the monitor. And there's a slightly simpler one that doesn't do the color as well, which hard coded, I think, to white on blue. Then there's our new output routine. This is, again, a similar wrapper to our input-output function, or the output function. In fact, the input is the key input routines I've already shown you. And what this will do is allows the C to print out to the Nanocomp display without any further complication. Then I've written my Nanocomp move function, which updates display row and display column values in the monitor working storage area, so that we can change where the next character will be printed to if you want to. If we don't overwrite this value, then what the Nanocomp display routines will do is move to the next column, next column, next column. If it gets to the end of the row, it will go back to the first column on the next line, and if it gets to the end of the page, it just goes back to the first line of the page. So it wraps round. Then we can see here that these are the values that I've defined for the custom characters. So these were originally done in assembly language. I've got a version of this is the program that I used to test this. So you can see that these are originally done in assembly language, but have now been converted into the C syntax but basically what the copy character generator ROM or RAM really probably should be, all it does is a simple routine that goes through these values and overwrites the character generator RAM values from F0 all the way up to FF. So then the Nanocomp header file just includes the things like the colors and some of the memory map values for the various ports, CRTC controllers, where the working storage RAM is for our Nanocomp monitor display routine. So again, if we change the Nanocomp monitor, we'd have to change these as well. And then we've got things like the keyboard definitions for the built-in keypad, the 7-segment display routine values that we need, and these are the routines we've already looked at, just the prototypes of those. And then probably the trickiest bit to work out was how to replace the curses, N curses, with equivalent functions to work with the Nanocomp. So it's probably easier to actually look at the header here to see what it does. So again, we've got the colors defined here, some of the keys that were defined specifically for the ncurses library, which we've redefined as being 7, 9, 8, and 4. Then there is a structure defined for the window. So the window has the number of rows, number of columns, the starting row and the starting column, the number of rows, the number of columns, and what the current displayed row and current column is. So what this basically means is for each window that's defined in the display area, we can maintain the current row and column that's been displayed in there and then translate that to the underlying main Nanocomp display. And what we've got here are some functions to draw a box around the current window. So this does the lines around it. To move the current print location to a particular window row and column, and then this behind the scenes will be converted into the underlying screen coordinates. Function to clear a window, just print general provided text and a numeric argument, and the function to create a new window based on the start row and column and the height, and then a helper function to create the color byte combinations based on the foreground and background colors. So the C routine here includes a bit more detail on how to do this. I won't go into this in great detail, but it makes a combination of the Nanocomp move functions, our print character, and the various other routines and things around here. What we've got here for the wmove is just overwriting the values for the current Windows display role, and then we're updating the Nanocomp values for that, including the start window, row, and column offset. in addition to the current row and column within the window. So the print W, I did have to do some messy configuration here. The original print W included a variable number of arguments, the ... syntax, and I did look at trying to reproduce this using some articles I came across, but it wasn't working very well. So what I've done is just hard coded this to one integer argument, which is all that this code uses. Something perhaps need to go back and look at. We've got the function that instantiates a new window, so basically just sets up the beginning XY coordinate, number of lines, number of columns, and sets the current display row and display column to be 0. And finally, our init pair function. So these are the functions I needed to write to take Steve's sort of current code and make it work on the NanoComp. So what I'm going to do now is to look at compiling this, and then we're going to download it and run it. Okay, so what I've got here is I've got Windows Subsystem for Linux running Ubuntu, and I've got the CMOC C compiler and the LW Tools assembler and linker. And this works quite nicely. I've been able to get this up and running fairly easily. There's a number of steps required to do this, and I might cover this in another video if people are interested. But what this will do is to produce a Motorola S Record output, which can be downloaded directly into the NanoComp using the load function in the monitor. So we get a few warnings where we've got some constant declarations and things for passing parameters into the WPrint, but nothing which is actually going to cause us too much trouble. And what this will have done is created an SREC file for main. So this will have created us a, you see main.srec has just been created there. And you can see that it starts at 000, so this is the execution address. It's quite big, and then there is some data at the 5000 range. So the data is at the 5000 range, and the program is in the bottom 8K. So we can see the size of this. It's about 24K in size, although obviously it's not this big because we've got 2 bytes for every character. So 2 characters for every byte, we should say. But in total, it's probably about 8, 10, 12K, something like that. So it's a reasonable size program. So we've now generated that. So we have the S record file. And what I'm going to do now is to just put the NanoComp into load mode. And we're going to go into the send file function. I'm just going to paste in. So this is the main SREC that we've just done, and I'm going to send this down. Now this does actually take a little while because by default the NanoComp I've got running at 9600 baud, so that's about 1 kilobyte per second. It does take probably about 30 or 40 seconds for this to download and for the prompt to come back on the NanoComp. So what I'm going to do now is go to the VGA capture card, and we're going to see if we can run Tetris. So what I've done now is reset the NanoComp. We've downloaded the code for the Tetris. So what I'm going to do now is to do go 0000, and this should run on NanoComp. Now what you can see here is we haven't done any of the optimization preventing some of the snow interference here. And if you've seen some of the earlier videos, you'll know that what we ended up having to do is to check to see when the display enable signal was disabling output between the video frames, and if we had just updated the display during that time, then we would find that the snow would disappear. But this is a little slow at the moment because what it's actually doing is every single clock tick it's redisplaying the whole page, even if it doesn't need to. So the ncursive library would only have actually output data to the terminal if the before and after images of the display were different. Whereas because I've written this to be used for this NanoComp version, then in fact you can see I missed that one there. But you can see it's actually running. We can see there's the colors here. The responsiveness of the keypad is not great at the moment just because of the timing loops we're having to use and not making it particularly easy. And what would really make this a lot easier is if we had the outline characters going down the bottom here. So we've got our next character coming, so let's just see. I'm not the world's greatest player of Tetris, and certainly not at this speed. Right, so if we can get that as far over to the right. Now the only issue at the moment is there does seem to be a bit of a gap on the right hand side here, so I do need to adjust some of the spacing here, but hopefully if we can get a solid row, I perhaps need to re-record this, do a slightly better go at doing this. And so the keypad responsiveness at the moment, the timing loop is not great, but hopefully it should. There we go. So we've actually now done a line completed. So hopefully that shows some of the functions. I can also do hold there. So by pressing the 5 key, it's actually put the eye shape there up in the hold area. So if I want that, I can press hold again and it will swap out the current character. But this will really need to be optimized a little bit to get slightly faster. Rather than displaying, at the moment we're displaying the entire page every single time there's a tick in the main loop. So this is not a very efficient way of doing things. There you go. So we've now got 2 lines left out of our. So can the Nanocomp run Tetris? Yes, it can. We need to improve this a little bit. There's a few updates we could do to improve the display and certainly make it more responsive, so it isn't quite as slow as this. But this is sort of taken some existing C source, which I think is designed to run on much more modern computers, and has now got it working for the Nanocomp. And you can see there we've also been able to suspend it, unsuspend it. And if I just get one more completed row. There we go. So we've done 5 completed lines, so that's probably sufficient for now. And if I press CN, then it shows me game over. I finished with 200 points on level 0, so could probably do a bit better with a bit more practice. So I've shown that we can run Tetris, if in a fairly inefficient way, on the Nanocomp. So coming up over the next month or so, during February probably, I'd like to improve the efficiency and performance. So at the moment the full display is updated every single tick, and I suspect that's because the ncurses library would look at what the previous image was and the new image was, and would only send updates to the terminal for those areas that have changed, which is fine on a very fast computer. You can easily do that, but on the Nanocomp it's only running at probably 500,000 instructions per second, and so we don't really have the horsepower to do that. So updating the screen only where required rather than the full refresh should certainly reduce some of the overheads. And I was also going to profile the hot areas of the application by using the logic analyzer on the address line, so that we can see what are the addresses which are accessed the most, and so we should then be able to get a good idea of which areas to improve. We also need to eliminate the video access RAM snow. In earlier videos we've seen that we can do that by checking for the display enable when it's disabling the output between video frames, and for each video frame there's probably about 1.6 milliseconds between the frames where we can update the screen without actually causing any snow. I would also going to look at hardware methods of perhaps changing the timing of the various signals so we don't get that effect when the computer is accessing the video RAM concurrently with the CRTC. And I'd also like to include outline shadow tetronymos to show the drop position as I showed in the test program a little bit earlier. So in answer to our question that we said, can this run Tetris? Yes, it can. There are a few improvements we need to make. There's a bit of screen formatting, a bit of gaps and things at the left and the right that perhaps we can improve, and we can certainly improve the performance. But what I've been able to show really is that the Nanocomp and its VGA controller card are able to run Tetris, if not very fast and very efficiently at the moment. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you found this interesting, please hit like.